Welcome back to the course on architectural design of ICs. So, we were discussing in the last classes that means the adder architecture. So, we have started with one that binary addition operation. Then we have discussed that means for n bit addition what are the adders are that means there are different adder architecture. So, different adder architecture for different aspects or different application. So, different application means somewhere I need high speed, somewhere my requirement should be low power consumption, somewhere it might be for low area consumption. Okay. So, we have seen that there are several type of adder architecture which are available. That means people have tried for to design different though the addition operation it do, that means the keeping the functionality same, how the architectural that means changes basically whenever we are doing the VLSI implementation at that time in the hardware architecture changes, how it affects the its major constant, that speed, power, area, that we are discussing in the last few classes about that there are different adder architecture like this. We have started with ripple carry adder, then we have seen that carry skip adder. So, in the carry skip adder we have seen that it is, if we choose variable sized carry skip adder, then it we are getting that means the delay is optimized. Then if we use multi-level variable block adder, that means this carry skip adder or block adder, then more the delay we can save, that means more the speed or the operating frequency you can achieve. Okay. And then we have seen that carry look ahead adder. So, this ripple carry adder and carry look ahead adder, these are the two basic adders we have already known from the basic electronics circuit design. But this is, that means from the ripple carry adder as the carry is rippling from LSB to the MSB side. So, for if the number of bits, that means the addition, if I require the number of bits is more, at that time the carry is more, sorry, the propagation delay for the carry signal is more. Okay. So, to reduce that we have designed what we have designed, or we have come to the point that if we can generate, we will not wait for the carry signal for that means rippling from LSB to the MSB side. So, instead what we can do, we can generate, and in each level we have that means we have observed and we have seen that the carry generation and carry propagation logic is there. So, identical, that means initially we can based on the input bits. So, we can generate and propagate the carry in such a way, so that the corresponding delay that can be reduced in carry look ahead adder. Okay. So, that we have seen. And whenever we are doing this carry look ahead adder design, so at that time we also have seen that though this carry skip adder or this look ahead carry adder, what we are doing, we are basically, that means the carry is basically traversing, or that the critical path which is follows in the like horizontal direction. But in case of look ahead carry adder, the that means the carry or the that means or the carry or the that means the propagation delay that follows in the vertical direction. So, why vertical direction? Basically that also we have seen, because this C0, that is this Z0 plus P into Ci, that means Ci plus 1, that is equals to Gi plus Pi into Ci. So, whenever this Ci means, that is the previous carry which is multiplied with this propagated one, that means Pi is nothing but A XOR B, and G equals to A and B. That means the G is the, that means generate the carry, which is the logic for which is A and B, and for propagating the carry, the logic is A XOR B. Okay. So, that has been ANDed, this propagated carry that has been ANDed with carry, previous carry, and now then we are getting, if we are just or with this generated carry, then we will get the next carry. Okay. So, like that way we just do that. Okay. That we have already discussed. So, here today we will see another things. In the last class also we have discussed that there is that fan in and fan out dependency. So, what is that fan in, fan and fan out dependency? So, and that we will see now. Okay. So, now we will see this delay optimized CLA. CLA means look ahead carry adder, carry look ahead adder. So, if you see, this is basically the work follows of Lee and Klobjaja in 91. Okay. So, here you see there are 4 different architecture which follows this CLA method. Okay. So, here you see the first one says that the fixed groups and levels. So, here you see each of the, that means whenever we are, that means generating the corresponding carry. Okay. So, the as we, if we just, so the carry signal Ci plus 1, that is basically Gi plus Pi into Ci. Okay. So, this Ci is the previous carry and Gi and Pi, logic for Gi equals to Ai Bi, and for Pi the logic is Ai XOR Bi. Okay. So, that means now if I just, whenever I will continue with this particular equation. Okay. So, at that time for C1 I will get some of the expression over here in corresponds to Ai Bi, then C2 I have to find out, then C3, then C4, then C5. Okay. So, something like this. But whenever we will see, suppose for C1 what will be the case, if I want to, Ci will be this G1 plus P1 into C0. Okay. So, then C2, what will be C2? C2 will be G2 plus P2 into G1 plus P1 C0. Okay. So, that means now this is G2 plus P2 G1 plus P2 P1 and C0. Okay. Then next what will happen? In next, again if I want to calculate C3, then it will be G3 plus P3 into this P3 into C2. Okay. So, now C2 is this value. So, if I just, that means replace this C2 by this value. So, at that time C3 will become G3 plus P3 into this G2 plus P2 G1 plus P1 P0 and C0. Okay. So, that means G3 plus P3 G2 plus P3 P2 G1 plus P3 P2 P1 and C0. Here you see, whenever we are just, that means this generating or we are getting the carry which is basically depends on only the first carry input bit, which what we basically know from the beginning, what is the carry last, that means carry in bit to the corresponding, that is 4 bit CLA or 8 bit CLA. So, what will be the this C0 that we know from the beginning. Okay. And what about this G3, P3, this and this P2, G1, this. So, if I just want to, that means if I just want to calculate this, so how can I calculate? Basically G3 is nothing but A3 and B3. So, this depends on the current input, and this G2, sorry, if I just want to calculate this P3, so P3 is nothing but A3 XOR B3. So, that means it does not depend, this carry that does not depend on the previous carry which happens in the carry look adder, ripple carry adder. So, in ripple carry adder the C3 cannot be computed unless and until this C2 is available to me, and C2 is again that cannot be calculated unless C1 is available to me. That means once the C1 competition of C1 is available, that means over, then only I can calculate C2. So, that means I have to wait for that time, but here I do not have to wait, because C0 is already available and all these signals all are available at that time only. Okay. So, that means that and by that we basically increase the or we decrease the propagation delay in carry loop adder. But at what cost? What we are doing here? We are just increasing this level. So, as I am considering this, so you consider for C3 I am getting this P3, P2, P1, C0. Okay. So, for then again for C3 this level again it will increase, that means here I need 1, 2, 3, 4. So, that means this 4 that means OR operation I need to do, then 1, 2, 3, 4. So, 3 of this AND operation I have to do for this particular thing. That means, whenever we will increase what actually I want to say, that is, if I increase this particular C for C8, okay. So, at that time for C8, suppose for C8, so at that time it will be something like this P7, P6, P5, sorry P5, P4, P3, P2, P1, P0 and C0. So, this level that will be the last term. So, it will increase something like this. So, at that time, so to implement this, what I need, what I can do, I need 1, 2, 3, 4, 5, 6, 7, 8, 9. So, 9 input AND gate, or else what I can do, if I am having this, that is why basically we are that means I said that there is fan in and fan out dependency, because this gate that fan in, if fan in is maximum of fan in is 3. So, that means it can take only 3 input bit, it cannot take 9 input bits. Okay. So, at that time if I just want to that means do this ANDing operation using 3. So, at that time what will happen? So, 3 then again 3 then again 3. Okay. So, then this 3. So, at that time this will be the circuit for implementing this. So, that means here what I am doing, I am just increasing the level. Okay. So, the logic level has been increased by, here it was just only one gate delay, one AND gate delay, but here it will be 2 AND gate delay. Okay. Now, if I say that okay, fan in is maximum, it is 2. So, if it is 2, then again it will increase. Okay. So, at that time that means the level will be increased. So, that means how the level will be increased, that it will log to as n. So, this means 16. So, 4 level I have to do. So, whenever we are considering this as 3, so log 3 base 9, that is equals to 2. Okay. So, that means for these particular terms, and there will be again for this OR operation will be there for this, if I just go back to this slide. So, for these particular terms will also increase. So, that means this OR operation will also increase. So, OR operation will increase means again I need this OR gate for the final that means ORing operation. So, I need one OR gate of 8 or 9 input. So, again if I say that okay, the thing is that means we have this fan in limitation of 2 or 3. So, at that time again the level will be increased something like this. Okay. So, that is why how we can basically optimize the CLA, that is there are, if we consider different kind of topology whenever we are implementing this for carry input, that means the carry bit. Okay. So, that means for different topology we will get different numbers in the corresponding critical path. Okay. So, here you see actually for fixed groups and levels. So, that means this fixed groups and levels means here I need what, that means the input corresponds to the corresponds to the gate is 3, then total 9 bit, again that has been ended or with this. That means this is one structure. Fixed groups and levels means where each of these follows the same number. Okay. So, then next is that variable size groups, but fixed levels. But here you see at the first level there are 4, in the second level there are all 2, in the third level it is 3. So, that means we are considering this 4 input gate at the very first level, and whenever we are at the second level, at that time we are following the, that means the level or the fan in of 2, and in the level 3 we are considering fan in of 3. Okay. Then another that means kind of topology will be that there, that means variable size groups and fixed levels. Okay. So, here the levels are fixed, but the groups are variable. So, here 4, then 2, then 3, but here the variable sized groups and fixed levels. So, here you see that means this number will be now different. So, here you see this is 2 2, then here 2 4, then 2 2, then here 3. So, that means the groups are different. Here I am having 2, here I am having 3. So, something like this, that means the groups are different, but the labels are fixed, which has 2 in this case, sorry 2 in this particular case. So, 3 for this case, 3 for this case. Then variable size groups and labels. So, here you see in this particular architecture both the groups and the labels both are basically variable. So, that means in different of this we will get different delay for the same logic implementation. Okay. Then this is the 2 level of logic implementation of the carry block. That means you see there are only 2 number of gate, that means this is the inputs. So, there are only 2, that means from input to the output there are only 2 number of gate delay in each of these particular things. Okay. So, here you see here for this the input are 2, for this is 3, for this is 4, this is 5. Okay. For this is 5, then 4, then 3, then 2, then 1. So, that means now if I just that means go back to the previous slide, at that time this says that okay, this is, if I just corresponds to this particular circuit. Okay. So, at that time what will happen, here 5 4 3 2 1 and here 5, then 5 3 2 1, then here 4. Okay. So, something like that means if I just draw it. So, at that time how it will look like, 5, then 4, then 3, then 2, then 1. Okay. Then this is of 5, then again sorry, yeah, then 5, 3, 2, 1. Okay. So, something like this. That means it has 5 input, it has 4 input, it has 3 input, it has 2 input, it has 1 input. Okay. Then again whenever we are considering this particular, if I just, so this is the 2 levels, the levels are 2 only, that means 1 and 2. Then next you see 2 level of logic implementation of the carry look ahead block. that means this is the another implementation technique. So, here you see instead of this vertical, if I just put it in the vertical, it will be just the same. And then 3 level of logic implementation of the carry block and with restricted fan in. So, restricted fan in means if I just that means restrict that, okay, the minimum number of the fan in will be 3 or 4. So, that means it cannot go beyond 4. So, at that time what will happen, the same circuit this in this case there was 5 input, and the 5 input if I restrict the fan in of 4. So, at that time what will happen, I need one AND gate which is basically doing this 4, then again I need another one where I will do this 5th number I will just consider. That means, initially it was considering only one gate, but here it is considering 2 gate. You just see, here I am considering only one AND gate of 5 input, but here I am considering one AND gate, then one NAND gate, that means one 4 input AND gate, then one 2 input NAND gate. Okay. And then again if you just see that another changes, here there was 5 inputs. Again I said that, okay, that for the gate the fan in is restricted for 4. Okay. So, if I just come to this, then again this is ANDed first in 4, then again it is NANDed with this and this to get this. That means, that 4 that now it has splitted into 2 levels. Okay. So, so this is the, that means for this if I just restrict to 4, for this if I just restrict to, if I can restrict to 3, in this particular case if I restrict the corresponding to for 4, for this also if I just restrict that term to 2. So, that means here in this particular case the fan in is restricted to 4, in this particular case the fan in is restricted to 3, in this case the fan in is restricted to 2. From the circuit basically I am telling. Okay. If you just go back, then you can see here we are having 4 input. If I just restrict for this particular things the fan in of 4, so at that time this circuit is very much okay, I do not need to change. When I need to change, when if I restrict this to 3, so at that time I need 2 levels here, 2 levels here. Here also if I just restrict to 3, so at that time it does not, that means it does not need any change. But whenever I will restrict the fan in to 2, specifically to 2, so at that time this will change like this. Okay. So, this is the 3 levels. So, that means whenever we are putting this, that means we are increasing, if we restrict the fan in, that means we are increasing the corresponding levels by 1. So, this is again this another implementation of this carry loop adder with restricted fan in. Okay. And if you just see this delay optimize this CLA, the performance of that. So, at that time you see this that means the straight line is this first one is the, and this is the basically delay, and this size, this is the number of bits, okay, or the size we that means that number of n if I consider. So, if you see that for fixed level CLA, okay, for 6 level CLA the delay are following this particular curve, and if I follow, if this dotted one, these are the variables, that means it can be in that variable size or groups, or fixed groups variable size, or fixed groups variable levels. Okay. So, 4 of the architecture we have seen, that means 4 of the topology we have seen. So, any from that that is a variable one. Okay. So, that in that case it follows a lesser number of delay. This is for 2 level of, that means CLA design. And if I follow 3 level of CLA design, so at that time also you see this variable that means level CLA, that gives us better result in terms of this that means critical path reduction. Okay. So, why critical path reduction? That means if I consider more number of that means if I consider, that means the fan in of 9. So, at that time, because of the loading effect or because of the parasitics which are related or which are associated with the corresponding gate design at the transistor level, that becomes too much high, which basically increases the delay. But here whenever we are considering lesser fan in gates, that means whether that is 2 or 3. So, at that time I will get more number of savings in terms of critical path or in terms of delay. Okay. So, though we have increased the that means level here and here, you see that means it is almost, that means this gaps are almost same for 2 levels, whether that is 2 level or 3 levels. Okay. So, then again these are the, that means another that means example of that, if I choose this delay optimized CLA circuit. So, at that time I can get the benefit. So, this is another example where we choose something like this 1 1 then 2 then 1 then 2 then 1 then 2. So, 1 1 means this is the one input. Okay. So, this takes 2 input, then again 2, here is 1 and 1 coming over here, then 1 1 2, then 1 1 1, that means this is the 3 input, and then 1 1, then this, then again 3. So, something, and finally, we are having 6 at this particular things. So, that means the maximum fan in is 6 over here. Okay. And for this, for this particular case, okay, here you see this is also the thing is that the maximum level is 6, but here what we are doing, that means somewhere here I am having 5, in this particular case I am having 5 and here I am having 6. Okay. But the levels if I consider, okay, so the levels if I consider, then 1, 2 and then 3. Okay. But here the delay is 8.5, but here in this particular case the delay is 8.9. In the previous slide also, if you just see, it has slight difference. If we increase the level, it has slight difference from the 2 level this CLA optimization. Okay. So, then for today's class, this is it. In the next day, we will see this carry select adder. Okay. So, thank you all.